Good morning, Tasneem. Welcome. Good morning, Ria. Welcome, all of you guys. Yes, Yogesh. Good morning, Parikshit. All right, all of you, very good morning. All right. So, guys, yes, we are going to continue our discussion and we have daily YouTube sessions. Okay. So, guys, today also we are going to discuss stereochemistry, some really important questions on stereochemistry we are going to do. And before moving onwards, guys, let me inform you and everyone who will watch this session, if you want regular notifications about the YouTube sessions or about any free classes or plus classes, you can join up on the CSINet 2022 Telegram channel, okay, for regular notifications of everything. All right, yes, very good morning, all of you. So once again informing guys that today 10 a.m. you are going to have this mock test. All right, 28th of August you are having this mock test for chemical sciences, all India mock test, and the day is today itself. ठीक है, तो आपको ये टेस्ट देना है, right? So that's why let's quickly start the discussion. Let's quickly do some practice before the test. Okay, and I have made you solve. यस, हाँ बिल्कुल परीक्षित कर सकते हैं गेट के लिए रेफर, नॉट अ प्रॉब्लम। एब्सोल्युटली गेट गेट के अंदर भी स्टीरियो केमिस्ट्री आती है, बहुत अच्छे वाले क्वेश्चंस आते हैं विच आर आल्सो लाइक रिपीटेड इन CSI नेट आल्सो। एब्सोल्युटली गेट एंड CSI नेट बोथ। ओके सो गाइज यस टुडे वी आर गोइंग टू डू क्वेश्चंस, ओनली क्वेश्चंस, ठीक है, क्योंकि मैं आपको ये मॉक टेस्ट में हेल्प करा रही हूँ इसलिए। सो लेट्स फर्स्ट ऑफ ऑल ड्रॉ the most stable conformation. See, of this particular molecule. Okay, so I'll be writing four options. You have to say which one is the most stable conformation of this molecule. All right, so this is one of them. Yes, so which one is the most stable conformation? Good morning, Ganesh. Good morning, everyone who have joined. Yes, guys. यस तस्नीम, आपको क्लियर नहीं दिख रहा है तो सेटिंग्स में जाके चेंज द रेजोल्यूशन, रेजोल्यूशन को 360 पे कर लो, इट विल बी फास्ट ऑल्सो, इट विल बी क्लियर ऑल्सो। ओके, चेंज द रेजोल्यूशन तस्नीम। यस, बी इज द करेक्ट आंसर, श्योर। ऑल राइट, तो गाइस व्हाट डू यू सी ओवर हियर, ठीक है, व्हाट इज द मोस्ट स्टेबल कॉन्फर्मेशन? स्टेबल तो बनाना है बट एटलीस्ट यू हैव टू टेक केयर ऑफ दैट इफ वी आर नॉट चेंजिंग द कॉन्फ़िगरेशन ऑफ द मॉलिक्यूल, इजंट इट? दैट इज, ये देखो, द इथाइल इज बिलो द प्लेन, you have to take care of that, so this ethyl has gone above, absolutely wrong. What about over here guys, the isopropyl or any bulky group like isopropyl, like isobutyl, or let's say simple butyl, and many other groups like which are bulky groups, they always want to stay on the equatorial position, and that's why C is wrong. ये तो axial में चला गया. What is going to happen अगर axial में जाएगा तो there will be 1,3 diaxial interactions. That's why it is wrong. Why is option number D wrong? D is wrong मैंने ये पूछा है स्टेबल बनाना है, लेकिन आपको मॉलिक्यूल चेंज नहीं करना है. हियर द मॉलिक्यूल हैज चेंज्ड. ऑप्शन नंबर डी, isn't it? The molecule has changed. It is actually this molecule where you have both the methyl and the ethyl below the plane. You cannot change the molecule. So D is wrong. In option number B, you have the methyl above. Yes, the methyl is above. And on the fourth position, isopropyl is above. Yes, and isopropyl is equatorial, which is a more stable conformation. And the ethyl is below, like this. So B is the correct answer. Yes, absolutely. Chalo, so let's do one more question and I will be asking you the order of stability of different conformations. Okay? So what is the order of stability of the cis and trans? Yes, guys, I'll give you nomenclature this time. Okay? 1,4-dimethyl cyclohexane. ये देखो प्रतीक अभी वही कर रहे हैं. Okay, so you want 1,2, let's take 1,2. ठीक है, 1,2 डाइमिथाइल साइक्लोहेक्सेन ये करते हैं. चलो, so let's say, ठीक है, let's say we draw it over here. For the cis molecule, we are first drawing the cis molecule over here. कितने possibilities है cis molecule के? You have one methyl, both of the methyl should be above, isn't it? So when both of the methyls are above, this is one possibility. ठीक है, और मैंने इसको कर दिया flip. What happens when I'm flipping? First of all, see if this is the cyclohexane, one of the cyclohexane. After flipping, ये जो नीचे है ये चला जाएगा ऊपर, ये जो ऊपर है ये चला जाएगा नीचे, ऐसे. So first just draw a zigzag line like this. This is a zigzag line in this way. First point is below, last point is high. ठीक है, flipped version में first point is going to be high and last point is going to be below, isn't it? ऐसे zigzag line बनाया, right? Now just make it like this, isn't it? Not very difficult. Okay, so this is the cyclohexane that we have right now. Okay, what happens is don't have to draw the hydrogens along with this, क्योंकि अगर hydrogen draw करोगे it will become more complex. So just take this one carbon. If the methyl is above, it is axial, and another methyl is equatorial. So we call it axial equatorial isomer. ठीक है? So ये वाला carbon कौन था? ये वाला carbon, right? Which has gone below now. So axial methyl changes to equatorial in this way. अबव का अबव ही रहेगा, कभी भी फ्लिपिंग से अबव का बिलो नहीं होता और बिलो का अबव नहीं होता. ठीक है, इफ द मिथाइल इज अबव इट विल स्टे अबव, बट एक्शियल टू इक्वेटोरियल इट चेंजेस. ओके, दिस वाज द मिथाइल विच वाज अबव और ये इस कार्बन पे था. टेक केयर ऑफ दिस, ये फ्रंट वाले कार्बन पे, सो इट इज गोइंग टू बी ऑन दिस. तो अबव का अबव ही है लेकिन इक्वेटोरियल टू एक्शियल. दिस हैज चेंज्ड. Okay, that is important. So take care of this. All right. So what do we do now? We draw the trans isomer. Okay. We draw the trans isomer. ये हो गया CH3 और CH3. What is this isomer? Since it is trans, एक above एक below है, so they are trans. We will call it the diaxial या तो AA isomer. Diaxial. ठीक है. If this is flipping, क्या करोगे? Once again, just take this carbon above ऐसे और इसको below ऐसे. All right. Obviously, you can draw better than this, but this is just to show you the zigzag line. All right. Now what happens is, let's write it properly first. ठीक है. सो व्हाट कैन वी डू, दिस मिथाइल, दिस कार्बन इज गोइंग डाउन, तो यहाँ पे आएगा ये मिथाइल, बट इट इज above, so above का above ही रहेगा, and that's why goes equatorial. This carbon is right over here now. Okay, so it is going to go below, but it is still equatorial. ठीक है guys, why have I not drawn it? ये देखो, जैसे ये था टू axial, why have I not drawn it in this way? एक तो चला गया equatorial and the other way. Why have I not written the methyl like this? Please pay attention. This is very important. The methyl will go in this direction, not in this direction. ये गलत है. Why is it wrong? Because whenever you are drawing the cyclohexane conformation, you have to see that both these sides you are forming this M. ऐसे M बनाना है यहाँ पे, तभी सही होगा. Okay? This one was not forming the M, isn't it? ये तो कुछ और ही बना रहा है, तो ये गलत है. Okay? So take care of that as well. Alright, so what is the stability order, by the way? What is the stability order of all of these conformation? Let's say I'm numbering them 1, 2, 3 and 4. Yes. What is the stability order? Let's say in the decreasing order. You are writing in the decreasing order. ठीक है, मैं इसको decreasing order लिखवा देती हूँ. Now what is it going to be? Alright, so the most stable one is going to be the di-equatorial form, isn't it? Most stable one out of all of these. So 4 is going to be most stable, and 3 is going to be least stable. Yes, trans can exist in most stable and least stable form. Yes, yes. 3 is most unstable. ठीक है. What about 1 and 2 guys? 1 and 2 में तो बराबर है. Axial equatorial, because the substituents are also same, isn't it? So 4 is greater than let's say 2, which is equal to 1, which is going to be greater than 3, isn't it? ये दोनों तो सेम होने चाहिए. Yes, absolutely Ganesh, very good. So everyone guys, yes, this is going to be the order. All right, now I'll ask you one more question, that which is a stable conformation for this molecule? Most stable conformation. Most stable conformation for this molecule. You have one tertiary butyl over here, you have another tertiary butyl over here. You tell me. I'm not drawing the options, you tell me. What is it going to be? The diaxial form, the di-equatorial form, axial equatorial, बताओ क्या होगा? Yes, axial equatorial. Let's try to draw. Let's try to draw guys कि मान लिया चलो that one tertiary butyl is below over here, but this side tertiary butyl has to be axial. इसको flip कर दो. Flip this one. What are you going to find? Okay, that this side it is stable. इस side में stable हो गया, but this side it has gone axial. So absolutely this is not going to be stable. Axial equatorial, equatorial axial, they are not going to be stable. ये क्या है? 1,4 cis है. This molecule is 1,4 cis molecule, isn't it? So 1,4 cis की possibility क्या है? Always axial equatorial, axial equatorial. ठीक है? Yes. Now these are not stable. तो हम क्या करेंगे? There's a question in CSI net also based on the same concept, isn't it? What is this concept guys? कि अगर cyclohexane stable नहीं है, let's say the cyclohexane is not stable, then you will form ट्विस्ट बोट, ऐसे करके, ठीक है। You will form the twist boat where they are on the pseudo equatorial position, ठीक है। So guys, see in the twist boat you don't have actually any equatorial position, उसमें equatorial axial नहीं होता है, but you call them pseudo equatorial, okay। Yes, all right, chalo, so this is one thing very very important guys. If the chair are not stable, we can go to the twist boat form as well, if obviously if it is there in the option। यस, मिरर इमेज नहीं बनाना सिखाया, चलो अभी सिखाते हैं प्रतीक, एंड लेट्स सॉल्व सम क्वेश्चंस। ओके, सो इफ आई जस्ट आस्क यू दिस सिंपल क्वेश्चन, हाउ मेनी configurational isomers are possible for 1,4 dimethyl cyclohexane, ठीक है। How many configurational isomers are possible? Yes, configurational and conformational, these are two different things, isn't it? अलग अलग होते हैं ना। So how many are possible? फ्लिपिंग से डायास्टीरियोमर भी बनता है, हाँ बनता है बिल्कुल। सो वही पूछ रहे हैं हम लोग कन्फिगरेशनल, लेकिन हमें फ्लिप नहीं करना है बिकॉज वी आर नॉट टॉकिंग अबाउट कॉन्फॉर्मेशनल आइसोमर्स। सो यस, 1,4 dimethyl cyclohexane. How many are possible? Yes guys, cis and trans, isn't it? cis and trans हो गए, ओके। सो हाउ मेनी? ओनली टू, ओनली टू, ठीक है। आर दीज टू ऑप्टिकली एक्टिव और इनएक्टिव? बोथ ऑफ दीज? Anybody out of these is optically active or inactive? Both of these are inactive guys, दोनों में sigma plane है। There is a sigma plane passing through this molecule, cutting the molecule into half like this. So both of these are inactive. Yes. चलो ठीक है, very well all of you, ये तो समझ में आ गया, very well. Now what we can do is we can do the same thing for 1,2-dimethyl cyclohexane. We can do the same thing for 1,2-dimethyl cyclohexane. Let's say let's try out. We want to find out the maximum configurational isomers, तो वही करेंगे। This is a cis and we have a trans. So configurational isomers में which ones are having different configuration? तो इसके भी दो ही बनेंगे, cis and trans. Yes. However, if I ask you what are the total number of isomers, या फिर if I ask you what is the relationship between these two molecules, ये दोनों क्या है? Yes guys, what are these two? Plane of symmetry in both. Both of these are enantiomer, but what kind of enantiomer? Conformational enantiomers या configurational enantiomers? That is the question. ठीक है, तो इसके पास में भी configurational isomer दो है guys. One is trans, one is cis. Very well, very happy we are. लेकिन अब ये जो मैंने mirror image बना दी, what is that? Conformational या configurational? Configurational, conformational. Yes, let's check, isn't it? Check करते हैं guys. So what do we see? मैंने इसको क्या किया? I have just made the mirror image of this particular isomer. What I'll do is I'll just try to flip this molecule in some way so that I can check whether it is superimposable with this molecule or not. Isn't it? तो मैंने क्या किया? इसको first of all मैं कर देती हूँ rotate ऐसे. How much I am rotating? I am, let's say, I want to bring this methyl over here, isn't it? I want to bring this methyl over here. तो मैंने कर दिया 120 degree rotation. 120 degree rotation कर दिया मैंने. So then it's going to look like this. The molecule is exactly going to be the same. लेकिन on 120 degree rotation, this one comes over here and this methyl comes over here. So the methyl is like this. क्या ये superimposable है? नहीं, अभी तक तो नहीं है. They are not superimposable as of now. Okay, very well. Now I am flipping this. Now I am flipping this. On flipping, what do I get? I get this molecule, that is ये वाला जो methyl है, this is going to be above and equatorial, and this is going to be above and axial. Okay, all right. Now can I rotate it a little bit? Can I rotate it 120 degree to check? Yes guys, कर सकते हैं rotate. ये देखो, ये this methyl can be rotated 120 degree. What do I get? ये रहा CH3 और ये 120 degree rotation से यहाँ पे आ जाएगा. So this is one more CH3. So finally guys, what do you figure out? By flipping or rotation, by any means, if we are not breaking any bonds, सिर्फ flip करने से या rotate करने से अगर ये वाला molecule मिल गया, which was the mirror image of this particular molecule, then we will say these two are conformational enantiomers. Have we got the same thing? Yes? Yes, isn't it? So, what is this? Conformational enantiomer. Conformational enantiomer. All right. So ये देखो. Does it make sense, everyone? Yes or no? Conformational enantiomers are those that by rotation or flipping you are going to get this molecule और कोई bond break नहीं करना पड़ा. You are getting an enantiomer. This is a mirror image. लेकिन कैसे बना? ये बना rotation और flipping से. Yes, प्रतीक. 120 डिग्री रोटेशन से कौन सा सब्स्टिट्यूएंट कहाँ चेंज होगा वो सीखना है. बिल्कुल देखते हैं, चलो एक बार. ओके, पर वो देखने से पहले गाइज लेट मी इन्फॉर्म यू ऑल कि फिलहाल अनअकैडमी पे क्या चल रहा है. A detailed batch as well as a practice batch is going on Unacademy right now, and this is really important that you if you want to subscribe on Unacademy Plus, you can just join through the code Jagriti S Live. For those who are looking for practice, you are going to get all the important questions in the practice batch, as well as I am doing some special classes जिसको मैं Battle of Pole बोलती हूँ. So in those battle of poles session, all those sessions are free basically, battle of poles. ठीक है, so attend those sessions for previous year questions, and for new questions you can attend the practice batch. Okay, yes. तो हम कहाँ थे? हम थे how to rotate, how to cause the rotation. See, this is 1, 2 and 3. Yes, Pratik, look at this. Good morning, Priya. Okay, so look at these three carbons. ठीक है, और इन तीनों को अलग से देखो. What are they forming? Are they forming a triangle? क्या ये ट्रायंगल बना रहे हैं ये तीनों कार्बन? Isn't it? बना रहे हैं ट्रायंगल. So tell me, what is the internal angle of a triangle? अगर मैं दोनों को ऐसे पॉइंट्स को कनेक्ट करूं, what is the internal angle of a triangle? Looks like 120 degree, isn't it? Yes. ट्रायंगल का इंटरनल एंगल 120 डिग्री होता है. यस. सो इफ आई रोटेट फ्रॉम हियर टू हियर, अगर मैं ए बी सी ट्रायंगल बनाया मैंने, ए बी सी, ठीक है. ऑल राइट. सो ए आफ्टर रोटेशन कम्स ओवर हियर, B is over here and C is over here. मैंने कितना रोटेट किया गाइज? I have rotated 120 degrees. So after 120 degree rotation, A goes to B, B goes to C, and C goes to A, and so on and so forth. So 120 degree rotation करना है, ठीक है. So when you are looking at these 3 points, they are making a triangle. So if you want to change the methyl, one methyl from here to here, जैसे कि मैंने चेंज कर दिया मिथाइल को, और मैंने साइक्लोहेक्सिन सेम बनाई है वापस से. मैंने साइक्लोहेक्सिन चेंज नहीं किया है. द साइक्लोहेक्सिन ओवर हियर and over here, they are the same. But after 120 degree clockwise rotation, let's say over here, this methyl turns out to be here. Isn't it? Yes. ये इधर आ जाएगा. Once again, I'll do the 120 degree rotation. So, yes. This methyl turns out to be over here. So, मैं क्या कर रही हूँ? Clockwise rotation we are doing, right? So, first over here, then another one over here. ठीक है. 120 and 120 रोटेशन. ठीक है. चलो अभी लेट्स गो बैक टू द क्वेश्चन. हम क्या डिस्कस कर रहे थे? हमने देखो क्या किया. दिस इज योर मॉलिक्यूल. हमने इसका मिरर इमेज बना लिया. ओके, एंड वी वांट टू चेक कि ये कॉन्फिगरेशनल इनैंशोमर है जिसमें दो अलग अलग मॉलिक्यूल होते हैं, वेयर द बॉन्ड्स हैव टू बी ब्रोकन. ठीक है, या फिर ये कॉन्फॉर्मेशनल इनैंशोमर है. वी वांट टू चेक दैट. ठीक है. यस. Yes, absolutely, Ganesh. That way also you can think, right? So what did we do, guys? हमें somehow check करना है whether any conformation I can get जो इससे सुपर इम्पोज हो जाए. तो हम क्या कर सकते हैं? हम रोटेशन कर सकते हैं. ठीक है. सबसे पहली चीज क्या आती है दिमाग में? रोटेशन करो सबसे पहले तो. ठीक है. एंड देन डू द फ्लिपिंग. सो मैंने रोटेट करवाया यहाँ पे इस मिथाइल को 120 डिग्री रोटेट कराया. दिस मिथाइल कम्स ओवर हियर, इजंट इट? ये मिथाइल जंप करके यहाँ आ गया. तो ये नीचे वाला जो मिथाइल है, दिस इज ऑल्सो गोइंग टू डू 120 डिग्री रोटेशन एंड कम ओवर हियर, इजंट इट? यस. लेकिन ये तो सेम नहीं है. दीज आर नॉट सुपर इम्पोजिबल. फिर मैंने फ्लिप करा दिया. ठीक है, चलो देखते हैं फ्लिप करके क्या आता है. फ्लिप कराया, ये भी नहीं है. बट आई कैन वेरी क्लियरली सी कि इफ आई एम डूइंग द फ्लिपिंग आफ्टर दिस, इफ आई डू द फ्लिपिंग, तब मुझे साफ साफ दिख रहा है कि ये जो मिथाइल है, अगर मैं इसको रोटेट करा दूं यहाँ पे देखो, देन इट इज गोइंग टू कम एट इट्स पोजीशन. और ये भी दिख रहा है दैट दिस मिथाइल इफ आई एम डूइंग 120 डिग्री रोटेशन, इट्स गोइंग टू कम ओवर हियर. दे कुड बी सेम. तो मैंने इसलिए 120 करा दिया रोटेशन, एंड इट इज एग्जैक्टली द सेम मॉलिक्यूल विच इज द मिरर इमेज. सो द मिरर इमेज ऑफ दिस मॉलिक्यूल हैज कम टू मी आफ्टर रोटेशन एंड फ्लिपिंग. मतलब कि एक सॉल्यूशन है हमारे पास 1,2 डाइमिथाइल साइक्लोहेक्सेन का. उस सॉल्यूशन में 50% this can exist, right? 50% of this can exist and 50% of this can exist, isn't it? Yes. So the molecule itself is not achiral. आप इस molecule को देखो guys, it is not achiral, isn't it? Because the molecule does not have a sigma plane. इसमें कोई sigma plane of symmetry है? Not at all. Yes. There is no sigma plane of symmetry. So the molecule itself could be chiral, but because of this internal, yes, because of the 50-50% it's going to stay as a racemic mixture, and Mohit, it is not resolvable. ये non resolvable है, non resolvable. Okay, चलो let's move onwards. तो ये तो हो गया guys conformational enantiomers वाला concept. Now we will see more questions. Okay, guys, did I make you do this kind of a question? ये देखो, what is the most stable conformation of this molecule, right? So let's say conformation A is in this way. I'm having two oxygens over here, and I have one methyl like this, and one OH over here, one OH over here. ठीक है? So ये एक molecule है, ये एक molecule है. Yes. All right. Yes, guys, most stable conformation of this in this molecule. You are having two alcohols and you're having two methyl. ठीक है, what is the best thing to be done? वन फोर बोट में नहीं होना चाहिए. नो ट्विस्ट बोट यू आर आस्किंग, वो वाला ट्विस्ट बोट तो एक्चुअल में इसलिए हमने दिया लिखा था प्रतीक, because there were two tertiary butyl groups, isn't it? So if we are having one tertiary butyl like this and another like this, ठीक है, so tertiary butyl is a group which absolutely cannot be kept on the actual position. That is why we had to take the twist boat. Methyl we can keep, okay? तो यहाँ हमें ट्विस्ट बोर्ड की जरूरत नहीं पड़ेगी. You can keep the methyls and specifically where there are oxygens. Yes, guys. So what do you think? Which is the most stable conformation? ये देखो हाइड्रोजन बॉन्डिंग तो है यहाँ पे भी. You can do the hydrogen bonding in this case. ऐसे करके it could be stable. Or let's say, चलो guys, obviously A will be correct, लेकिन मैं आपसे ना order पूछ लेती हूँ, ठीक है? I have drawn different conformations, so let's discuss the order of stability. ठीक है? So order of stability is going to be maximum for A, isn't it? Because you have a hydrogen which can do the hydrogen bonding from this side, and this side also hydrogen bonding is possible. So A is going to be most stable, and the methyls are also present on the di-equatorial position. A is the most stable. ठीक है? What is going to be next? Yes. What is going to be next? Now in option number C, there are only two lone pairs on the oxygen. पीछे वाला oxygen और ये सामने वाला oxygen, ठीक है? Right? So what happens is these two oxygens, they are not going to have cause the 1,3 diaxial interaction. इसीलिए this methyl is stable on the axial position, not a problem. So C is going to be better than option number B, जहाँ पे these two hydrogens are doing 1,3 diaxial interactions with this methyl. Okay, so A is greater than C, which is greater than B. Alright, so this is your stability order. ऐसे order पे questions आ सकते हैं, or you can also you know, have which one is the correct, which one is the most stable, and so on. ऐसे करके भी आ सकते हैं. ठीक है? Yes. Now guys, if I ask you one more question, one more similar question, इसका तो आपने देख लिया that if we are having an oxygen, yes, Ganesh, we will consider that too. If we are having an oxygen, we have some alkyl group and we have a hydrogen. So, alright, a question could be asked like this also, that this is A, this is B, and I have something very similar over here. I have sulfur, for example. ठीक है? Yes, sulfur. Sulfur के लिए CH3, H, A, H and CH3 like this, B. अच्छा, जस्ट अ सेकेंड गाइस, थोड़ा सा चेंज करना है क्योंकि ये इतना इम्पोर्टेंट नहीं है. दिस पार्ट इज नॉट ऑफ रेलेवेंस. What is the important thing to be considered is the 1,3 diaxial interaction. ठीक है, so we will do some changes in the molecule. इसको हम रख देते हैं ऐसे. Yes, Chetan, mock test है, absolutely mock test starts from 10. Yes, most stable. So let's discuss this, guys. Now, the whole important focus of this question is कि maybe the methyl is not having 1,3 diaxial interactions with oxygen. So इसलिए we can say that out of A and B, there is not much difference. Okay, the molecule can exist in A also, molecule can exist in B also. ठीक है, this is not a problem. लेकिन ये जो methyl यहाँ पे है, all right, in option number A, where there is sulfur, then this is going to have a problem. Why? Because of the size. Size should be bigger. Bigger size of sulfur, so greater interaction with sulfur, and A is going to be less stable than B. Okay, here the A is almost equals to B, but here the A is going to be very less stable than B because of the size. Okay, so ये एक important चीज है. फिर अगर ऐसे आ जाए, yes Ganesh, you were asking that let's say we are having the chlorine. So due to the anomeric effect, yes, you have a Cl over here. So due to the anomeric effect, this is going to be more stable. I just hope that you are asking this only, that when the chlorine is present, where is it going to stay? Yes, is it going to stay in the equatorial position? No, because then there will be the repulsions in between the lone pair. The oxygen has two lone pair और chlorine के पास में तीन lone pair है. Yes, this oxygen also two lone pair, chlorine has a all of the lone pair repulsion there will be. इसको हम बोलते हैं rabbit ear effect. Okay, it is known as the rabbit ear effect, and that is why you will not have this stable, more stable because of the anomeric effect like this. ठीक है? Yes. So, and yes, guys, plenty of things, plenty of important examples to be discussed in stereochemistry. आप जितना बुक्स से पढ़ोगे उतना ही ज़्यादा बेटर होगा आपके लिए. And guys, once again, reminding all of you that you have the mock test starting from 10 a.m. Okay, so yes guys, visit the link. It is already 10 a.m. और हम कल फिर से कंटिन्यू करेंगे tomorrow the same time 9:15 a.m. All right, and I just hope and I wish all of you all the best. और आपको क्या करना है, जाके मॉक टेस्ट देना है जल्दी से and score really really good because you have some really exciting offers over here. Amazon voucher मिलने वाला है फर्स्ट सेकंड थर्ड रैंक के ऊपर. सारे केमिकल साइंस में आ जाए तो मजा ही आ जाएगा. ओके, चलो. So yes guys, bye everyone. Start the mock test. We'll see you super soon. Bye everyone.